in my introduction, I would like to start with really why I'm here today. I'm a cloud architect, and all technologists like you here, I enjoy solving problems that involve scale, large scale and high impact. And like most of you here who believe that technology without a meaningful application is just an expensive toy. Would you agree with that? I think I did hear some anecdotes today alluding to that. But what is meaningful use of technology? Depends, right? So it depends on where we are. And of course, the very basic is that yes, technology achieves a business outcome and gives you the return on investment. But maybe sometimes it's also good to look at it in a different way as to how technology brings about a positive change in the lives of the disadvantaged. For example, how about helping a poor farmer in an emerging economy understand soil conditions? Bringing mainstream education to people in their local language, or helping a hearing impaired enjoy Mozart. And it is one such meaningful use of technology that I have been pondering over the last 10 years, thanks to the multiple wars and conflicts that we've been seeing in the last 10 years. I work for INVB, and that's given me perspectives about the complexity of emergency management. And that's what I'm here to talk about today, to talk about how technology using data and AI has the potential to reduce decision loops to save lives. So let's start with a question. What do I do next? Seems like a rather inconsequential question, right? Unless you're in this situation. And at this point, the question not only becomes consequential, it becomes critical. Because the decision that you make will decide whether you're ever going to ask you this question ever again. Tough one? Let's turn it a few notches higher, right? Let's make it a little more complex. Imagine that you were working with 3 unfavorable options that you are aware of, and 1 million favorable options that you are not aware of. And let's say that you had to make a decision anywhere between 30 minutes to, well, if you're lucky, 4 hours. And that's the time that you had to evaluate or assess the risk of the decisions that you want to make. Is that complex enough? No? Okay. Let's say that you had to take this decision with the sound of low-flying aircraft saturating your hearing, smoke clouding your vision, or the smell of death overwhelming your sense of smell, your breath. Welcome, you're officially in a large-scale emergency, natural or man-made. And look at yourself, unless you're wearing a uniform, you have not trained for a situation like this. you are officially, or you have formally climbed to the top of the panic pyramid of decision making. And a panic pyramid of decision making is when you have a broad range of alternatives, too much to select from. Sometimes choice is not the best thing. You have a very short time to decide on what next, and you have an impaired perception. That's definitely not the pyramid that I want to climb. The pyramid that I want to climb is, no, not that one. And yeah, that. So emergency management is actually, humor aside, emergency management is actually a very deep topic. And it has multiple facets that are beyond the scope of the use case that I would like to illustrate. And the use case that I would like to illustrate is war and high intensity conflict related displacement. We've been seeing this in the news quite often. And I want to focus specifically on two phases of emergency management, which is preparedness and response. Because there's a lot that happens during emergency management, before emergency management and during emergency management. And what's critical over here is data and how you decide using that data. Perhaps all of us know that, or have experienced situations when we've got a lot of data, but really don't know what to do about it. So we'll get to that. So typically when it comes to emergency management, in terms of preparation and response, there are a number of activities that happen, which is pre-positioning of human aid and resources. We might think that, hey, when there's an emergency, people magically appear and pull everyone out. No, there's actually years and years of training and practice that goes into it. There are standard operating processes that are defined. Those are shared with people. Training and capacity building for emergency responders, that's training. Establishing contingency plan for mass evacuations. And usually it's not just a simple, hey, I go in, pull someone out, come back. No, there are multiple scenarios that need to be considered, and the best course of action needs to be picked out of that. What's really complicated is there are multiple organizations that come together. It's not a single enterprise. And that's what I mean by really stretching technology, right? I think all the story about, hey, getting in streaming data, processing it, sharing it, is really very feasible within an enterprise ring fence. Here we're looking at, hey, there's not just a single entity, there are multiple entities who are playing different roles depending on what the situation is. So that was preparedness. The other one is response, right? Which is, hey, what do you do? Get in, do an immediate, evacuation, provide shelter. Emergency medical care and psychological support. And this is what is building up to that story, because psychological support is a very, very, very key aspect of emergency management. You see, most people die. Most people suffer not because they don't get the medical care. They suffer because they give up before care arrives. And so that's important. Of course, distribution of food, water, and essential supplies. Great, sounds good. But where? How would you know? What you need to drop where? And, I have seen I have come across a lot of instances where relief was actually dropped far away from where people needed it. And people actually perished in the process of going and trying to get it. Protection of vulnerable group, and this is going to be very important in the discussion, right? We're dealing with a lot of data over here. And that data can be used to identify target groups with malicious intent. But that's really the challenge of the scope of emergency management. Now, the challenges in emergency management, which we may not probably see in an enterprise environment is that the scale and federated structure of human disaster management. We spoke about this, multiple agencies involved, and we'll see another complicated picture of that later. Inaccurate risk assessment. It's one of the larger reasons that, hey, how do we decide whether it's safe to put our rescue team in? We have seen news about aid workers getting killed in the process of rescue. Delayed and inefficient response times, that's pretty clear. Adapting global SOPs to local conditions. So the way emergency response works is there's usually standard operating processes that are defined by a larger agency, but then it varies country to country. And sometimes cultures are different within the country. For example, there was a country where a medical team was sent, but the medical team was all men. And as per culture over there, women did not see any other male other than their immediate family members. So, and this is a very simple example, right? So the standard operating process has to be quickly adapted to local requirements. Misinformation and reliable sources. How many people have lost their lives because during a mass evacuation because they saw something in Twitter and decided to follow what was there, only to realize that wasn't the truth. And the constraint in the existing solutions is that there's difficulty in real-time data collection and synthesis. It's because of the fact that this is such a fragmented environment, right? Who's responsible for what? It depends on the situation. There is no system that's in place that's constantly streaming data into a central data repository. It's all need-based, right? Teams appear, materialize, they set up their infrastructure, they move. Fragmented and unreliable sources. Yeah, some of the sources are official, some of them are unofficial. What one central agency may say is very different from what a local agency may say. Manual data processing and analysis. Yes, a lot of information actually comes through calls, which people make a note of, and then they do a risk analysis, send back. There's a lot of time that's just lost in communication. Limited predictive capabilities, and I'm talking about analyzing risk based on an emerging situation. So usually disaster management is treated as, so I came across this word during the event that happened in Baltimore when a ship ran into a bridge, and the official press conference said that we are dealing with an evolving emergency situation or evolving emergency situation. There is actually a technical term for that. I didn't realize that. And what that means is we don't know what our next step is going to be because we are still figuring it out. So, complex enough? Let's make it a little more complex. Right? We'll simplify it later. This is how it actually pans out. And I want to talk about some very interesting anecdotes over here about how emergency evacuation works. So let's take an example. Let's take a war situation. So there is a country that's trying to get its citizens out of a war zone. So that country doesn't really put boots on the ground because that's infringes on sovereignty of where the event is happening. So they work with United Nations agencies, they work with international NGOs, they work with local NGOs, they work with local administration, they also work with press. And who would have expected this? Sometimes you have to work with militias, pay them a ransom so that they can guarantee a secure passage for your citizens. And then, of course, right, eventually there are different risk zones. So there are some really high risk zones where nobody wants to get in. Then there are medium risk zones. There are different risk classifications of the risk zone, and the affected population is over there. Now, this involves a lot of information. It involves a lot of communication, and it involves a lot of decisions. And all of this takes time, may not always be reliable. So there is a sense of risk involved, right? So actually, in a situation like this, to be rescued, you actually need a guardian angel. If you're in a situation like this, you need a guardian angel. And so let's call our solution guardian angel, right? Transforming crisis response with data and AI. So how would a reimagined emergency management solution look like? Given the fact that now technology has evolved, right? It's no longer people sending in, calling using phone, or I think there was a time when there used to be a fax that used to come out, right? Or something that used to come out in a dot matrix printer, right? By the time you have read through the document, there are probably already lives lost. So leveraging data, real-time data streaming is important. And there are a lot of devices. There's a lot of metadata that devices are sending. And to pick, Damien's example, right? Which is, hey, by looking at the clicks on the remote, you can actually figure out what the person is doing. And these can be employed even in the devices that are sending data back, right? For instance, hey, if a camera which is supposed to only capture images is all of a sudden running continuously, which means that there is already a mass movement of people. Integrating AI for predictive insight, like I said, there's a lot of scenarios that have to be dealt with, quick decisions made. Seamless collaboration and communication across command center and field, right? So there is somebody telling someone else, what do you need to do next? Now, where does streaming data and AI come into this? Well, there are a lot more devices sending data these days than we could have ever imagined. And I go back 20 plus years when I was working in the energy industry. And there was real-time data captured from all the oil and gas platforms. But by the time that it would come to a central server, you cannot take any decisions. So the decisions had to be taken in the control room, which is on the platform. How much time do I have?
Little bit less.
Little bit less is 5?
Let's go for 5.
Let's go for 5. Great. So yes, so there is opportunity for streaming data, continuous data, instant data processing and visualization, creating a real-time situation awareness. But where AI adds the icing on the cake is really for risk assessments and scenario simulation, factoring into account multiple more scenarios than what was previously possible, and responding back quickly. Generative AI for collating and validating the information from official and social media to figure out really, hey, what's the real version of truth? Conversational AI to disseminate contextual information. This is where, the psychological support. Imagine that you could just type in or you could just call into a number and a voice speaks to you, almost a human-like voice speaks to you saying, hey, you're fine. That's what really we want to hear when we are in an emergency situation. So data perspective.
Lost and Rex, but
yeah, you will survive. That's the key aspect that we want to hear. So yes, that's a lot of technology out there. But what I want this screen to bring out is, yes, the data element of the challenge is one aspect. But to make a solution like this work, we really need to get multiple other things in place in a scenario like emergency management, because security and compliance, right? You're not getting an end user agreement signed by people on how your data is going to be used, but your data is being used. Communication infrastructure. What do you do if somebody cuts the power in an area where there's, and there is no mobile network, right? The solution is like, hey, you'll get a call on your mobile and somebody will say, you're fine. Smoke signals, or maybe satellite, or, we have all the technology now, like establishing a wireless command post aerially. Cloud, of course, right? Devices and data types. But this is where all that data that's coming in, sometimes, a lot of data is not really a good thing, right? A lot of useful data is the good thing. And that's what we want to create here is, from all that noise that's coming in, how do you, get clarity? How do you go from chaos to order by processing the data and actually using it to send a signal back to people, which can save their lives? Now, I think, hey, is this, who's going to pay for this, right? First question is, that sounds expensive. That's a lot of compute and that's a lot of data storage in there, right? Who's going to pay for it? Second question could be, hey, is this an ivory tower that we are trying to build? And the answer actually is that the United Nations has been thinking about something like this already. And there is the United Nations Office for Disaster Risk Reduction has a framework called the Sendai framework. And one of the 7 target activities that they have is to build an early warning system to include, early warning is to build a multi-hazard early warning system. So that's what this is about, the MHEWS, where you're constantly collecting data before an emergency, creating a risk profile, right? Risk assessment, and then you're collecting data, real-time data during the emergency, trying to put them together to determine what's the next course of action. But yeah, again, the key aspect is, yes, we can, we have technology to get data where we want, but then security is paramount, right? And in a scenario like this, where there's no clear data ownership, right? Who owns the data? Because you're getting data from everywhere. Do you have the right contracts established with everyone on what data you can use and what data you cannot use? I mean, can you even apply GDPR to a situation like this? So that's tricky because all this data is a honeypot for threat actors. This is something that needs to be worked on, but that's the beauty of technology, right? As technology evolves, it creates more opportunities to evolve technology. And I see that with a situation like this, there's going to be, of course, a lot of investment in securing data, securing AI solutions, which some of our presenters have already talked about. So yeah, there are some limitations, of course, right? The first thing we spoke about is you have to stay online all the time for this to work. Lost hardware is lost hope, right? What if you use your mobile phone? These are some valid objections, right? You can follow the crowd. Costs an arm and a leg and a bank vault. Yes, it does. It is going to be expensive, but that's where, when your priority is saving lives, and if you're working in a global entity, perhaps like the United Nations, then this is worth the investment. And a note of caution, right? Because we are really dealing with something very important. We're dealing with life, so I don't want to trivialize the fact that hey, it all can be done. So data and AI related technology, it reduces the margin of error. It does not completely eliminate it. So that's something that we want to first, tell ourselves over and over again. Until AGI, perhaps. Okay, what does AGI mean to whom? That's a different question altogether. So yeah, all I would say is we are all technologists over here. Let's try to push the envelope. Try to figure out, use cases where we can really say, hey, I'm done with this technology. Let's move on to the next, right? Let's get something more, because it goes back to a mentor for my photography. What she told me once when I wanted to upgrade to my first DSLR, she said, Andy, the only reason you should move from one camera to another is when you've completely exhausted all the technology capabilities of your current camera, then it makes sense to move on to your next camera. But until then, keep pushing the margin.